See, I am Sunil Deshpande, and in this episode, we will discuss some problems connected with one-dimension and two-dimensional motion. I have certainly tried my best to pick up some interesting ones. And the first one goes like this. See, this is a balloon moving upwards at 29 meters per second, and a stone is dropped from it, and it reaches the ground in 10 seconds. Find the height of the balloon when it was dropped, and the acceleration due to gravity has been given. See, what you are supposed to understand here is the initial velocity of the stone which was dropped from the balloon. And I am sure students have a slight confusion about this because of the word that the stone is dropped. The moment he says that the stone is dropped, most of you are of the opinion that the initial velocity of the stone is 0. But before that, you should have a very clear understanding about the frame in which you are going to solve the problem. If you want to solve the problem in the ground frame, don't forget that the balloon is going upwards at 29 meters per second. Therefore, the initial velocity of the stone will be 29 meters per second in the upward direction. Acceleration due to gravity has been given in the downward direction. Use s equal to ut plus half it square and get the height from where the stone was dropped. So, just see. So, s equal to ut plus half at square. S is to be found, u is 29, and I have taken it to be positive because it is upwards. Time in which the stone reaches the ground is 10 seconds, minus half 9.8 into 10 square. So, what you get here is 290 minus 490, because 9.8 divided by 2 will be, I think, 4.9, into 100 will be 490. So, what you get is minus 200 meters. So, this indicates that the displacement of the stone before it reaches the ground is in the downward direction, which you have taken as negative. So, how do you read the answer and how do you interpret it? You can say that the displacement of the stone is 200 meters in the downward direction, and the correct option is B. See, here we have one more interesting question. Let me read it for you first. From the top of the tower, two stones A and B are projected, one vertically upwards and the other vertically downwards with the same speed. As usual, you have been allowed to neglect the air resistance, and then the question is, which of them will hit the ground with the greater speed? And the interesting part of this is, most of you will be of the opinion that the one which has been projected downwards will hit the ground with greater speed. But see the fun. Say this is the tower from where you have projected the particle with a velocity u upwards, and let us call the particle to be A. This is the ground where the stone is supposed to reach. But what will happen to this? As you have projected it vertically upwards, it will continue to go upwards with a decreasing velocity, and finally, after having reached the maximum height, its velocity will become 0. See, it is going against gravity, so naturally its velocity is supposed to decrease. After having reached the highest point, once its velocity becomes 0, from there onwards it will start falling down. And by the time it comes back to the level from where you had projected it upwards, its velocity will be exactly u but in the downward direction. So, there is absolutely no difference between A and B. A was projected vertically upwards and B was projected vertically downwards, right? But after A reaches the level from where it was projected, it will have acquired the same speed as B in the downward direction. So, then why should A and B reach the ground with different speeds? Both of them are going to hit the ground with the same speed, and therefore, the correct option is supposed to be C. One more interesting question. See, a body is projected upwards. The times corresponding to the height h while ascending and descending are t1 and t2. Find the velocity of projection. See, what he has given here is a particle has been projected upwards and it is going to be at a particular height h from the ground twice during its journey. I hope you agree with this, because if you project the particle vertically upwards, say we are talking about this particular height. So, while ascending also it will be at that particular height, and while coming downwards also it will be at the same height. But the times taken to be at that particular level are going to be different, because one will be while ascending and the other will be while descending. And he says the corresponding timings are T1 and T2, and he wants you to write the initial velocity of projection in terms of those times, T1 and T2. So, what you can directly do here is use S equal to ut plus half at square. See, h equals ut plus half minus g into t square, right. I have taken minus g because it is in the downward direction and the velocity of projection is in the upward direction. Okay, now if you simplify this, I think you will get gt square minus 2 ut plus 2h equal to 0. I hope I have done it correctly. So, I have just taken 2 as the LCM and I have transferred this minus gt square to this side. So, it has become plus, then minus 280 and then plus 2h is equal to 0. If you compare this with your standard quadratic equation, you will notice that in place of a there is g, in place of b there is minus 2u, and in place of c there is 2h. Therefore, if you try to write the sum of the roots here, it is going to be T1 plus T2 is equal to minus b by a, which is nothing but 2u divided by g. And this directly gives you the value of u as u equal to T1 plus T2 into g by 2, right. So, u is T1 plus T2 into g by 2, and that makes the last option correct. So, here we have one more question. Let me read it for you. A person throws balls into the air upwards at regular intervals of 1 second. The next ball is always thrown when the velocity of the previous has become 0. Find the height to which the balls rise. See, this is the question. So, there are two things that you can notice here. For the first one is the balls are being thrown upwards at regular intervals, and that interval is 1 second, which means after having thrown the first ball, the next ball is going to be thrown after a gap of 1 second. So, this is one assurance that he has given, and the second assurance is only when the velocity of the previous ball has become 0, the next one is going to be projected. So, which means the time which the first ball has got is 1 second, and in that time it has exactly reached the maximum height. Okay, how did we conclude that? See, because only when the ball has reached the maximum height, its velocity is going to be 0. So, there are two assurances given to you. We will use them mathematically and try to get the answer. So, the first thing that I am going to use is V equal to u plus at. V equals u plus at. So, V is going to be 0 because the ball will have reached the maximum height. U we do not know, let us say it is u only. It is going vertically upwards, so I am using acceleration due to gravity as minus. I can put the value as 10 later, into time is given to be 1 second. So, what you get here is u equal to 10 meters per second. So, this is exactly the speed with which he has projected every ball, and now he wants you to find out the height to which this ball is going to rise. So, what I will do, I will use v square is equal to u square plus 2as. V square equal to u square plus 2as. Again v is going to be 0 because at the highest point the velocity is going to be 0. U square we have already found out. So, let me write it as 10 square, again minus 2 into 10 into s, right, again minus 10 because vertically upward velocity is taken as positive, therefore, the acceleration due to gravity which is in the downward direction is supposed to be taken as negative, and what you get here is 100 equal to 20 s and s equal to 25 is 100 I think, so 5 meters. That makes the first option a correct option.